So welcome guys. This is Physics AR YouTube channel. Okay, and right now we are going to discuss about class 12 concepts in our channel now. Okay, so class 12, that too, it is based on NCERT syllabus. I'm going to discuss. Okay, in that NCERT syllabus in class 12 physics. Okay, you will be having the topics based on three important concepts. Okay, the total whatever the 14 chapters you are having in your class 12 physics NCERT can be divided into three parts. One is, what do you say, electricity and magnetism. One is electricity and magnetism, and another one is optics, that is the concepts that are related with light. Okay, and another one is modern physics. Okay, we can divide this physics class 12 syllabus into these three parts. Okay, so right now we are going to discuss about the electricity and magnetism part. Okay, so the first chapter we are going to discuss in this class 12 physics concept, it is from the topics of electricity and magnetism. So if I start one part in this particular chapters, we will be completing all the chapters that are related with electricity and magnetism. Then we will be moving on to the chapters that are related to optics, and at the last we'll be discussing the chapters related with modern physics. Okay, so daily, some around 15 to 20 minutes of video of based on each concept, it will be coming towards you. Okay, so I hope you people can understand the concepts and you will be supporting to this YouTube channel by subscribing to the channel. Okay, right, so let us come to the first part of this electricity and magnetism. Okay, so anyway, basically first initial topics will be based on electricity. Okay, so in this electricity we are having different chapters are there, but anyway, let us start with the first chapter. You are able to see here directly, that is electric charges and fields. Basically in this first two chapters are electric charges and fields. Okay, electric charges and fields, this is the first chapter. The next one is electric potential and capacitance. Okay, so these two initial chapters in the class 12 syllabus, okay, they'll be dealing with regarding charges at rest. That means electric charges when they are at rest. Okay, what different phenomena or what different physical properties do they possess, that we are going to learn now. Okay, so these two chapters combinedly, they will also be called as electrostatics. Okay, those are called as electrostatics. What is meant by electrostatics means it is regarding the charges. Okay, in your childhood you might have learned regarding electrons, right? Okay, electrostatics means it is about the charges. Static means being at rest. Okay, static means being at rest. So charges when they are at rest, what are the different phenomena or what are the different properties the charges possess, that one we are going to learn now. Okay, so first of all, let us try to know what is meant by a charge. Think on it. What is meant by a charge? Okay, yeah, you might have got the thought about it. Okay, so generally this charge we represent it with a symbol called Q. Okay, every physical quantity which we are going to discuss, for that there will be a name and as well as there will be a symbol to represent it in physics. Is that okay? So here, what is meant by charge? Okay. So now we have to know what is meant by a charge. Okay. What is a charge? It is just like, for example, every substance. Okay. If you take anything into your hand or which you can physically touch it and hold it, no, they will be having some mass. Okay. The amount of matter contained in a body, we call it as mass. In the same way, few substances, okay, when they are placed in electric or magnetic fields, okay, like suppose if you are placing a body in an electric or magnetic field, no, that if that body or if that particular body, if it is getting influenced by electric and magnetic fields, okay, if that particular mass, if it is able to get affected by the existence of electric and magnetic fields, then that property of that substance, we call it as charge. Okay, so to be clear, it is property of a body to be affected by both electric and as well as magnetic fields. So that property which is responsible for that body to get affected by both electric and magnetic fields, no, that property we are calling it as charge. Okay, so this charge is generally represented by symbol. Already I have given you that. What is a symbol for charge? It is a Q. Okay, we represent it with sometimes as capital Q, sometimes as small q, depending on the question, okay, how it has been given. Okay, now this charge is generally a scalar quantity. Scalar means it doesn't have any kind of it doesn't have the direction, but it will be having some only the magnitude, and its SI unit is, it is generally represented in the unit of Coulomb, represented by capital C. Okay, the SI unit of charge is Coulomb. Okay, and there is another one, that is the CGS unit. CGS unit of electric charge is, it is stat Coulomb. It is the stat Coulomb. Okay, or sometimes it is also called as, there is another one, that is electrostatic unit. Electrostatic unit of charge. Okay, it is also called as electrostatic unit. Then obviously we need to know what is the relation between SI unit and as well as CGS unit. Okay, so look at this. SI unit, that is the Coulomb. 1 Coulomb is equal to 3 into 10 power 9 stat Coulomb. Okay, 3 into 10 power 9 stat Coulomb, or it is also ESU. Is that okay? So that is the relation between SI unit and as well as CGS unit of electric charge. Okay, now there is another unit for this, that is Faraday. There is another unit for the charge, that is Faraday. Okay, and here generally 1 Faraday is equal to 96,500 Coulomb. Generally in chemistry they will be discussing about this particular point. Okay, 1 Faraday is equal to how much charge, my dear? It is equal to 96,500 Coulomb. Okay, now so generally where do we observe these charges? Okay, you might have like for example, you might be feeling some during or for example, if you are combing on a dry hair, okay, if you are combing on a dry hair, okay, and near to that comb, if you are bringing some small bits of paper, okay, that comb will be able to attract few small bits of paper to it. Okay, it will be able to attract it after combing. Okay, so this attraction, it is actually possible due to the charges only. Okay, and sometimes you might be seeing the lightning. Okay, when it is about to rain or during the rain, okay, you will be able to find the lightning from the sky onto the earth. Okay, that is also related with charges only. Okay, or for example, sometimes when you touch, or when you get up from a chair and if you touch someone or something, some substance, you will be able to feel some spark will be coming between you and that particular substance, right? Okay, so these all are in your day-to-day life, those are linked with the charges. Okay, right, now let us proceed with few more points regarding this charge. Now these charges, they are actually divided into two types. In the nature, we are dividing the charges into two types. Okay, that is, first one is called as positive charge, and second one is the negative charge. Neutral, being neutral, it is not a charge. If there is no charge, or if the net charge on a body is zero, then we say that the body is neutral in nature, so that we don't consider it as a type of a charge. Okay, so here, how did we come to know that there are two types of charges? Means, for example, like you take a glass rod. Okay, what I'm saying, glass rod, and you take a silk cloth. Okay, you take a silk cloth, and if you rub them together, if you are rubbing on this glass rod onto that silk rod continuously, then what happens is, after you remove them, like we are conducting, let us assume that we are conducting the same experiment in two different ways. Okay, here also glass rod only, and this is silk cloth. Okay, in two cases we are rubbing them like that. Okay, now after that you separate them. Okay, now if you are bringing this glass rod to near to this glass rod, okay, they both are exerting a force on each other to move away from each other. That means they are trying to repel from each other. For example, if you are suspending one glass rod something like this, okay, after rubbing to that silk cloth, if you are taking that glass rod, if you are hanging that glass rod something like that, and if I am bringing another glass rod nearer to it, then what happens is, this glass rod is trying to move away from that second glass rod. If you take this as first one and this as second one. Okay, at the same time, for example, if you are bringing this glass rod nearer to this silk cloth, they are getting attracted to each other. So based on this, we have divided, sometimes there is a attraction happening there, sometimes there is a repulsion happening there. So based on these only, we have divided the charges into two types. That is, one is the positive charge and another one is the negative charge. Okay, so in the nature, we know that each and every substance is made of atoms. Okay, in these atoms you are having protons and as well as electrons. Neutrons doesn't have any charge, my dear. Protons are said to be of positive charge. I'm going to represent them as plus E. Electrons are said to be with negative charge. Okay, so here what is meant by E, sir? E means it's a value that is 1.6 into 10 power minus 19 coulomb. Okay, the charge of electron is minus 1.6 into 10 power minus 19 coulomb. Charge of proton is plus 1.6 into 10 to the power of minus 19 coulomb. Okay, so generally if you take any atom, the number of protons, for example, let us take, what do you say, helium we will take. Okay, let us take helium. In helium, at the center in the nucleus, you are having 2 protons, and outside them you are having again 2 electrons revolving around it. Okay, so if you consider this total atom, okay, what is the net charge here? Total charge Q is equal to charge due to positive charge plus charge due to negative charge, because charge is a scalar. You can directly add it, no need of vector addition and everything here. So what is the net charge here? It is plus 2e, because there are 2 positive charges, that is protons. And here what is the net charge here, or due to electrons? It will be minus 2e. Okay, yeah, here there is plus, but actually charge of electron is negative, no? So that is minus 2e. Now if you add these two, what is the net charge there? 0. So that's why the net charge on that atom is said to be how much, my dear? 0 coulomb. Okay, so therefore we say that as there is no charge there, we call it as generally neutral, I said, no? So atom is electrically neutral. Atom is electrically neutral. Okay, for example, if you take, like for example, let me take it like oxygen. Okay, oxygen atom. In oxygen atom, you will be having 8 protons and as well as 8 electrons. Okay, for example, if I remove 2 electrons, then how many electrons will be remaining? 6 electrons. Is that okay? You have removed 2 electrons. So due to that, how many electrons are remaining in that oxygen atom, my dear? 6 electrons are remaining. Then what is the net charge on this? Q is equal to, due to positive charges, what is the charge? Plus 8e. Due to negative charges, it is minus 6e. What is the total charge here? Plus 2e. If you look at this carefully, okay, what is the charge of E? E means it is 1.6 into 10 power minus 19, which is equal to plus 2 into 1.6 into 10 power minus 19 coulomb. 2 into 1.6 is 3.2 into 10 power minus 19 coulomb. Okay, so if you are removing electrons, the body will become, if you are removing electrons from an atom, then that atom becomes positive charge. If you are adding electrons, already 8 electrons used to be there inside. For example, if it is 8 electrons and if you are adding another 2 electrons, then this will become, instead of 6 electrons, for example, if there are 8 electrons and further you are adding another 2 electrons, then total charge will become negative, that is plus 8e, and you added 2 electrons means total 10 electrons, right? So it is plus 8e minus 10e means it will become minus 2e. Okay, so if you are adding electrons, then that atom will become negatively charged. Is that okay? Right? But generally here, by addition of electrons, the mass of electrons is generally very, very small. Okay, when compared with protons, mass of electrons is very small. So due to that, we don't consider much change in its mass. Okay, we don't consider the change in mass of the substances in this case if you are adding or removing electrons, because mass of electrons is negligible when compared with mass of protons. Okay, regarding that what is the mass of proton and electron, that we will discuss in the upcoming classes. Okay, so that is regarding the net charge on that atom and all. Now let us discuss few more properties of charges. Okay, that is, another one is like charges repel each other, unlike charges attract each other. Is that okay? Like charges repel each other, unlike charges attract each other. Like charges means it can be positive positive or it can be negative negative. Okay, those are called as like charges. For example, one charge is positive and other charge is negative, then in that case also it will be, in that case it is called as unlike charges. So that's why in that case they will be attracting each other. Okay, next few more points, that is charge is always conserved. Charge is always conserved. Okay, what is meant by charge is conserved means charge is neither created nor destroyed, but it can be transformed from one body to other. Okay, it neither created nor destroyed. Okay, but can be transferred from one body to other. Okay, the next one is charge is invariant. Charge is invariant. What is meant by charge is invariant means, for example, the charge, for example, you take electron. Electron is at rest or when it is in motion. Okay, or that electron when it is in motion. Okay, the magnitude of the charge on it doesn't change. It will be constant only. That is the meaning of charge being invariant. That means the magnitude of the charge on that electron will not change whether the charge is at rest or in motion. Okay, next, the third one, that is important one, that is charge is quantized. Charge is quantized. What is meant by quantizing? Okay, quantizing means no, the quantity of that particular physical quantity. Okay, how much charge is present, it is always an integral multiple of charge of electron. Okay, charge on a body is always represented as integral multiple of charge of electron. Okay, I understood few people are getting confused. What is this quantized? Okay, now for example, let us take the strength of your class. Okay, let us take the strength of your class. Okay, for example, there is a student called Ramesh and his friends. Okay, the total strength of his class is some Okay, 31 members let us take. So the total strength you are going to take it, you are going to tell it as 31 students only, right? Okay, you cannot mention the total strength of the class as 23.8 students. Okay, or you cannot mention the total strength of the class as 19.7 students, like that, right? Okay, so it is always an integral multiple of student. In the same way, on a particular body, for example, if you look at this carefully, oxygen, when we removed electrons, we wrote it as plus 2e, isn't it? You remove 2 electrons, then what is the charge on that oxygen atom we got? Plus 2e. Is that okay? Yeah, value is there, but anyway, initially we got it as plus 2e, isn't it? For example, if you have added that electrons, we got that net charge as minus 2e. If you see clearly, this plus 2 and as well as minus 2 both are integers. Okay, so that means the charge on a body can be written as plus or minus n into e, where n is number of electrons added or removed. If you are adding electrons, it will become negatively charged. If you are removing the electrons, then it is said to be positively charged. Is that okay? So for example, you are removed, okay, if 8 into 10 power 16 electrons, if 8 into 10 power 16 electrons are removed from an atom, example I am telling, my dear, are removed from, not atom, from a substance. Okay, in an atom you can't have these many number of electrons. Okay, so 8 into 10 power 16 electrons are removed from a substance. Okay, then what is the charge on that body? Okay, just a small point. Okay, so Q is equal to given, okay, what are the given quantities, my dear? N is equal to 8 into 10 power 16, and you removed the electrons, right? What is the charge of electron, my dear? 1.6 into E value, I already said that it is 1.6 into 10 power minus 19 coulomb. Okay, so according to charge is quantized, what is the net charge on that body? Q is equal to plus or minus Ne. If you are removing the electrons, okay, then it will become positively charged or negatively charged. If you are removing electrons, okay, it will become positively charged, so it will be plus N into E, which is N into, what is the charge of N is how much? 8 into 10 power 16 into, what is the charge of electron? 1.6 into 10 power minus 19. Is that okay? So which is 8 into 1.6, it is how much? 12.8 you will be getting. So it is 12.8 into 10 power minus 3 coulomb, or it can also be written as 12.8 millicoulomb, because 10 power minus 3 can be written as milli there. So I hope you understood, my dear. Okay, so these are few basic points about the charges in the bodies. Okay, so from this particular point we are going to continue it in the next class. So see you for the next video. Thank you all.